Now, last but very much not least, we have Ari Gargir, CEO of RedC Biotech Limited. Welcome him to the stage.
I have to remove the mic.
Thank you.
Stand on the white.
Okay. Hi, I'm Dr. Ari Gargir, founder and CEO of RedC Biotech. RedC is developing an industrial process for the production of universal red blood cells for life-saving transfusions and for advanced therapies. Back in 1990, I went paragliding. I sucked at it. I crashed. I blew up my 2 lungs. I lost a ton of blood. And you could see me in the picture here in field surgery getting my first blood transfusion. So I'm literally standing here thanks to a blood transfusion that I received. But I've learned that many people aren't as lucky. Millions of people around the world die from insufficient blood supply or from unsafe blood. It's estimated that about 2 million people die every year from blood loss, from injuries and violence. 200,000 women die every year in childbirth from blood loss. Millions of people around the world suffer from blood disorders, and they're dependent on blood transfusions to survive. Sickle cell anemia, thalassemia are extremely prevalent in the Middle East and Africa. Sickle cell disease, children, about 300,000 children are born every year. Half of them will not reach the age of 5, and most of them are dependent on blood transfusions. Red blood cell transfusions are essential in many medical treatments, trauma, operations, childbirth, chronic anemia, and cancer treatments. About 120 million blood transfusions are donated every year. It's a $20 billion market, but it's probably double that size because there's a 100 million blood unit a year shortage. In the past, in the COVID pandemic, shortages were widespread, also in high-income countries, and this all has to come to a change. RedC Biotech is here to revolutionize this. We are developing a patented industrial process in bioreactors using stem cells, and we will provide universal red blood cells at high standards, pathogen-free, and free of undesired blood components. We are now scaling up our process into larger reactors, and when we reach economy of scale, the cost of a blood unit will be competitive with the cost of a donated blood unit. The production will take place in manufacturing sites around the world, in the local regulatory systems, but also near the hospitals where it's needed. At last, blood transfusions will not be a national treasure anymore. The blood transfusions will be an off-the-shelf pharmaceutical commodity, and the most important is that we will be independent of volunteer donors. The cost of a blood transfusion today is up to $200. Our target is to produce 1 blood transfusion in up to $50. So saving lives will also be a very profitable thing. To develop this disruptive technology, we're aided by thought leaders in blood transfusion medicine, red cell biology, stem cell biology. We have a team of experienced stem cell scientists. We're collaborating with Axelta in the Technion World Health Organization and academia and hospitals around the world. RedC Biotech is going to revolutionize this immense market. We're going to provide safe, abundant blood units everywhere for everyone, saving millions of lives. The last point while I was talking here for 5 minutes, 20 people died from blood loss. So think about it. Red-C Biotech is here to change this. Okay.
Thank you for that fabulous pitch. Let's turn to our judges and get some questions.
Definitely, it's a disruptive idea and disruptive product. And it will solve a lot of problems in the world. My question is, how would you overcome the regulatory issues for approving this product and sometimes religious issues? I mean, we have these, and some people don't want to get something, they don't know from where it's coming or something.
Okay.
So can you highlight this, please?
Great. Regulatory, the product will have to meet the requirements of regulatory systems in every country. That's a given. We could not give it to people. On the religious side, there's the ethical side. There is no religion who does not want to save lives, and I'm sure this is common with all religions, and this is the most important part. The other parts that are practical is that, first of all, the stem cells that we will be using are not what we call embryonic stem cells. They're from adults, because we have to take very specific stem cells from people that have a unique characteristic of universal blood. And when there is a baby, embryonic blood cells, you do not know that. So with that, I don't believe there's not a technological problem and nor an ethical problem.
I really like this. I think it sounds really interesting, but in terms of competitors coming into this market, can you tell us a little bit about your IP and about how you're going to protect that? And is this something that's easy to copy?
Well, first of all, it's biotech. It's hard to copy. But we have, the technology that we're using for production is heavily patented. It's a technology that spun off from the Technion in Israel, which allows the production of very high concentration stem cells as single cells in bioreactors. There aren't a lot of competitors at this point, but the technology is in its philosophy similar to what cultured meat is today, taking stem cells and producing them in very high volumes. Each industry has its standards. The standards for production of blood for injection are very high. It will be hard to meet. There aren't many competitors out there doing what we're doing, and the technology that we're using is especially fit to take us to the scale, because the whole story here is scale, coming out of the lab and taking it to biggest scale that you can.
So I saw as well that you had the World Health Organization on one of your slides. Can you tell us a little bit about that relationship, and is that part of how the
relationship with?
The WHO?
Yeah, so part of what I've been doing is reaching out to many users, hospitals, blood banks, and part of my interviews were the groups in the World Health Organization. I especially connected with a group that's sitting in Brazzaville, and they're in charge of African states, about 47 African states, and we're planning on doing a collaboration together, of bringing our technology to be tested in their region.
I think we're going to have to wrap up there. Unfortunately, we're running out of time, but can we have a huge round of applause for Ari Gargir? Thank you. I want to say a huge thank you to all of our finalists. Didn't they do a fabulous job pitching? Give them a round of applause. Now, our judges have some very tough decisions to make. While they are making those decisions and deliberating, we're going to have a short break. We'll be going into the room on my left, this side. We are very tight on time, and we have a very important guest speaker coming at 4 p.m. So make sure to be back in the room for 4 p.m. While you're out there enjoying